In this video, I'm going to talk about permutations and combinations. And I'm going to use these little red, green, and blue squares. I'm going to calculate the permutations for 7 objects, between 1 and 7 objects. And I'm going to show you the official equation. It looks kind of nasty, but I will walk you through it. Imagine I have 3 squares, red, green, and blue. And for a combination, the order does not matter. If I have a green, blue, red square combination, a red, green, blue square combination, it's still only one combination. For permutations, the order does matter. I can take these 3 squares and make 6 permutations. Now let me just fill in all the squares and all the different permutations, and I will have 6 hopefully. There's 1, 2, 3, 4, 5, 6 permutations without repeating. And only one combination. So we have 6 permutations and 1 combination possibility. So now imagine I have 4 squares instead of 3. I still can only make 1 combination from those 4 squares, but I can make 24 permutations. I can rearrange them 24 different ways for 24 permutations, but I still only have 1 combination. I am going to show you the permutations of different number of objects. I'm going to start with 1 and end up with 7. So with one object, it should be pretty obvious. There's 1 permutation. Now with 2 objects, I have a red and a green object, and I can sequence them 2 different ways, or order them 2 different ways, and that gives me 2 permutations. So I take 2 times 1, and this is equal to 2. With 3 objects, I have a red, green, and blue. So I have 3, which is n. 3 is n. 3 times 2 times 1, which gives me 6 permutations. Now I have 4 objects, so n is equal to 4. So I have 4 times 3 times 2 times 1, like that, which equals to 24 permutations. Now I have 5 objects, or n is equal to 5. And I take 5 times, you guessed it, 5 times 4 times 3 times 2 times 1. And this is equal to 120. And now I'll imagine I have 6 objects. And you probably understand now it's going to be 6 times 5 times 4 times 3 times 2 times 1. And this is equal to 720 permutations. Now with 7 objects, this is my last one, I have 7 times 6 times 5 times 4 times 3 times 2 times 1, and that equals 5,040. And it turns out I can take these 7 objects and create 5,040 different permutations. You probably noticed the same pattern, the 7 times 6 times 5, and then 6 times 4 times 3 times 2 times 1, and so on and so forth. I can't read that fast. And then I have 4 times 3 times 2 times 1, and so on and so forth I go. There's a word for this, and a symbol too. It's called factorial. So the shorthand notation for 2 times 1 is 2 factorial. The shorthand notation for 3 times 2 times 1 is 3 factorial. You're probably guessing this one's 4 factorial. And 5 times 4 times 3 times 2 times 1 is equal to 5 factorial. Again, this is shorthand notation, so you don't have to write this out every single time. And the last one, of course, is 7 factorial. So you might even see it written like this in your textbooks, or your professor does it this way. The only thing the factorial symbol means is, like in this case, 3 times 2 times 1 is 3 factorial, and 2 factorial is 2 times 1, and so on and so forth. Also, 1 factorial is 1. Now, if I want to know the number of permutations, I just take the number of objects I have, factorial, and this is my permutations. So if I want to know how many different ways can I organize these 4 objects, it's 4 factorial, which is simply 24. Now, the official formula is this: n factorial divided by n minus the small n factorial. In other words, how many different ways can I organize these 5 objects? Take an n at a time, the number selected. In this case, it's 5. I'm taking all 5. And this is equal to 5 factorial divided by 5 minus n, which is 5. I'm taking all 5 of these objects and all this factorial. This is equal to 5 factorial divided by 0 factorial, which is a new idea maybe for you. And it turns out 0 factorial is equal to 1. But so is 1 factorial is equal to 1. It's one of the mysteries of math, and I'll maybe discuss that in another video. I will discuss that. So now I have 5 times 4 times 3 times 2 times 1 divided by 1, which is equal to 120. So it turns out that I have 120 permutations and 1 combination. And 120 permutations. I'm probably repeating myself. In the next video, I'm going to talk about how to calculate permutations and combinations if I have 5 objects. And let's just say, for example, I pick 3 at a time. I pick those 3, or those 3, or these 3, or maybe some in the middle, like the green one, the yellow one, the purple one. And I'll use 2 different equations. And this is equation again for permutations, and this is equation for combinations. Notice I just add that one little thing. Again, I'll discuss this in detail in the next video, and see you there. Share the knowledge and share the love. Like us on Facebook, Google+. You can find us on Twitter. Questions and comments below, and don't forget to subscribe because I'm always posting new things. And the next video is coming right up.